विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।
Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Priyanshu and post-production by Professor Kaushik P. Kanchan of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. GCU, emphasis on life. GCU, emphasis on life.
Today's guest is Dr. S. Angappane, a distinguished physicist with an impressive career in scientific research. Dr. Angappane completed his PhD in physics from IIT Madras in 2004 after earning his MSc from Pondicherry University in 1998 and his BSc from Tagore Arts College in 1996. Dr. Angappane has been a key member of the Centre for Nano and Soft Matter Sciences, CeNS, Bangalore, where he's contributed at various levels since 2008. He's currently a Scientist F at CeNS, having worked his way through roles as Scientist C, D, and E over the years. His career also includes valuable postdoctoral research. Experiences at prestigious institutions like SKKU in South Korea and JNCASR in Bangalore. With a wealth of experience in nanoscience and physics, Dr. Angappane's research continues to drive innovative advancements.
Since 2008. My specialization is oxide nanomaterials. I basically work on developing different types of oxide materials by both physical and chemical methods. The physical methods, like we use a different type of deposition techniques like sputtering, e-beam evaporation or pulse laser deposition. The one thing especially to say, I make a deposition called a glancing angle deposition. So unlike the regular deposition where there is a vertical deposition happen, in this type of glancing angle, the material will be collected in the glancing angle. So this type of deposition will give very good nanostructures in a physical method. So after this preparation of this material, then we'll go for fabrication of different devices. Okay, I fabricate kind of devices for gas sensor applications, memory applications, and structural colors applications. So this gas sensors application, that's the one our current work where I am working more, like where we develop different types of nanostructure oxide materials, and these materials will be used for sensing different toxic gases in principle. So we develop sensors to work with different concentration of these toxic gases, okay, and which work in different ambience, different temperatures and different it's a kind of a different RH conditions actually. It's a kind of how much is a water vapor concentration in the envelope. It depends on the sensor's response. So what we do is we develop individual materials, then we combine this material and make a sensing platform. This platform is like array of sensors arranged in one platform. Now each sensor will be sensitive to each gas. So it's called a selectivity we call. So one sensor will have a high response towards a particular gas. Okay, the sensors usually having a problem of like kind of overlapping signals. The same sensor will have a response to some other gas also sometimes. So what we do is we will take individual sensors which is selective to particular gases, and like that some 6 gases. Yeah. So 6 sensors will be there in a platform. Now in these 6 sensors we expose to mixture of gases, and this mixture of gases we analyze by using different algorithms. Okay, that is what our research interest in this. Apart from that, I work on resistive memory circuits. So resistive memory is nothing but material which is having different resistance states. So by applying a different bias, you can change the resistance of the material to different levels. So these materials can be used for the multi-level memory applications. That is one aspect of our research. Another aspect, we work on the structural colors. See, unlike the natural colors where we use dye or other pigments, that's what is usually create colors. Whereas in this case of these materials, where the nanostructure, the light interaction with the nanostructure on the surface will give colors. Okay, the example is like color of the sky. The sky is blue color. There is no dye or pigment there, but still the blue color comes because from the scattering of different particles. Right. So that's basically cover my area of research, and like I work on both academic as well as the industrial research. I have some 6 PhD students are working under my guidance, and industrial projects running, and I have some government projects. Okay, about 6 students have completed under my guidance so far. The industrial research was like one project, whatever the gas sensor project. I have industrial collaboration.
Okay.
At Tata Steel, we had a project like where we developed a sensing platform. Essentially, like they want a sensor to be used in their factory. For example, the steel industry, a lot of poisonous gases, the corrosive gases will come out. So they want a sensor to identify these gases and to give a warning signal to the workers. Okay, this is very important because if you see these poisonous gases, many of these gases are odorless. Okay, but if it's going above certain ppb level, like without even knowing the reason, the person will die. Okay, so such a situation, this type of gas sensors are very crucial.
Something like Bhopal incident.
Yes. Okay, so this is like one of the project which we work with the Tata Steel. We develop gases for the industrial usages. So similarly, it is not limited to that. It can be like kind of expanded to several other fields as well. There was one project requirement came like where they develop a biogas plant, and they want to measure this gases, what are the gases is coming leaking from the plant. So like they were asking us to prepare gas sensors for that. And apart from that, we have one interest with a Danish company, a Denmark company, where they make breath sensors. Like usually that whenever you breathe out, there is a like volatile organic compounds in that breath. Okay, these organic compounds people like identify and quantify. From there, they identify what kind of disease is there in the body. So each disease having a biomarker. Okay, when a person is having some particular disease, when whatever he is breathing out, okay, that will carry the biomarker corresponding to a disease. So if we can identify that gas, that VOC, that is a volatile organic compound, then you can identify the disease. So that is one of the applications which we are into. So these are all the fields. Yeah. The future is 2 aspects. One is the industrial use. As I explained, the industrial pollution, for example, the industrial pollution monitoring, these gas sensors playing a major role. So essentially, these sensors are like the industry is like it will be continuously monitoring and mapping the gas concentration over time. Okay, so the companies like what the companies or governments, they know that the industrial area what type of gases surrounding that area. So these are all the one interest there. And apart from that, the pollution control, we are always interested. But there are like kind of lot of competition because the automobile emitting gas will be like very difficult to analyze. Okay, this is like one point it will be used. So both the industrial use as well as the pollution control it will be used.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization, catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and also through Spotify, YouTube and Apple Music platforms.
आइए हम सुने विज्ञान की अनकही कहानियाँ।